It is a really complicated topic, I would say, quite complicated. And my teacher started and my class started to learn the topic today. So the basic idea goes like this. So you're in this brush is too big. Also, if I'm looking sluggish, I'm using my left hand, because my right hand is basically unfunctional right now. So, how do you worry yet, right? So, here is the axis, and this is the material guideline. So this is material 1, and this is material 2. And the basic idea of this thing is that, right, lights refract. And what I mean by that is that when passing through two mediums, light changes. So this one can be air, and this one can be water. A really common example. So obviously, air has a lower density level than water. So therefore, actually, let me do this quickly. Change it back. Boom, boom. There we go. There we go. And when this happens though, let me change color. Let me change color quickly. Let's change one to red. Nice and simple. And this is what happens when, say this is light coming down this direction. And because water have a high density in air, the light will refract in direction towards the norm. This is a norm. Though typically we don't exactly draw like that, and more like a dotted line. So let's change that very quickly. So more like a dotted line, and like that. And you can quickly tell from this direction right here, the light changes. And the degree of the light is calculated from the norm. So this is the middle line, the norm. We call the norm because it's a 90 degrees from the material change. This chart can also be the same chart can also be shown like this. So let's change colors. Let's keep it the same here. Alt. There we go. Wait, is it alt? Nah. There you go. That's alt. So the material line can be also like this as well. Hello, brush tool, work for me. Well, freaking stinky. Let's find green instead to make this not too confusing. So this could be a material. Stinging bastard. So this could be the material. So this could be the material, and this can be a norm. And this can be your material 1, and this could be your material 2. And so light can reflect this way and go off that way. So we represent the refraction of the index by this, and the refraction of the reflection is represented with a capital R. And that's the basic that you need to know to it. And this is what you know as a refraction index. Refraction index is basically the density of the thing. It correlates to density. So, as explained before, as the air has a lower density than the water below here, right? Water. It will retract backwards. I don't know how that works, but it does how it works. And the index of refraction is the amount of you can say light is reflected back. So the denser a material is, the less refraction it's gonna have. For example, the air right here that has a lesser density will have a density will also have a higher refraction value. That means actually no. So for this for air which has a lower density will also have a lower refraction, and the water which also has. One second, let me check if that's correct. So yeah, so air which has a lower refraction, a lower density value also have a lower refraction value. For the water which has a high density also means a high refraction. And the way you can tell by density is basically how far away it is from the norm. The closer to the norm it is, the higher density is, and the further away from it, such as here, means it has very low density. In which case, it's even lower than air, which I'm not sure what the hell that is. And let's get rid of this very quickly. Yes, no, I don't need to. I just need to Control T, drag this to the top, and everybody can see. Okay, nice. Let's continue. New layer. So one of the more important things to remember, is this rule. S equals 1, sin 1, sin I over sin R equals V1 over V2, N2 over N1 equals the wavelength 1 over wavelength 2, and those can all be interchangeable. Where velocity v equals velocity n equals refractive index and that equals wavelength. And that's the basic that you need to know. So this is one of the questions that my teacher gave me today. A ray of light wavelength of 6 times 10 but powered by the -7 meter is incident from the air into a block of glass with an incidence of 30 degrees. The refractive index of air is 1.0 and that of glass is 1.5. Calculate the angle of refraction. So, the first thing to do in this situation is to simply draw it out. Not you, bastard. B, here we go. Draw it out. So we know coming from this side is 30 degrees. So, wavelength equals 6 10 minus 7 m. Refractive equals 1 and refractive 2 equals 1.5. Nice. So we both know. So we want to find reflective. So that's sin. I think that's sin. Yeah, so we got sin. Sin index and sin reflective. So using this form right here, those guys, sin 1 over sin R equals n 2 equals n 1. So this one is mentioned first, so that will be n1, and that's mentioned second, that makes it n2. Yeah, this will always probably. So anyways, n1. So we need to find this one. So this will make it sin 30 over sin r over 1.5 over 1. We want to find r. That equals sin r over sin 30 equals 1 over 1.5. Making sense so far? It doesn't, I know. I have 1.5. Okay, so since sim r is right here, this equals 1.5 times it by sin 30. If you put that in calculator, that would give you approximately 19.41 degrees. Nice. To calculate the angle, so you need to use sim signs. And because you want the sim r at the top of it, you need to flip the equation around on both sides. Control T, drag it down, and right. Let's put it right there. And let's move the equation downwards here. Into the second question, B. When you calculated the speed of light within the glass. Nice. So this one actually, I think pretty simple actually. Yeah, this one's pretty simple. So we need to start a new layer. So we got both for the sims. So we know sim I over sin r is equivalent to v1 over v2. We know v1. V1 is the first material, so therefore the one mentioned first, which is by logic air. So v will be equal to c, the speed of light inside a vacuum. The normal speed of light. And speed of light is equivalent to, I forgot, oh yeah, 3 times it. Equals 3 times by 10 powered by the 8, I believe. Yep, that's the answer. Nailed it. And then wait, so you got both of these 3 answers. All it takes is a bit of rearrangement. So, once again, you want to flip it over. Like. So what you need to do, it becomes sin r over sin I. So you need to flip it around again. And that becomes v2 over v1. v2 is equivalent to sin r over sin I times it by v1. So sin r is equivalent to about 19.41 over sin I, which is, I believe, was 30. Wait, let's check. Reflective eyes and sin 30. Nice. Times by velocity of 1. 1 that is equal to 3 times by the 10 of 8. Oh god, I have a most horrible handwriting. Be warned, never draw with your left hand. That's a 10 asshole. Okay. And when I put it in the calculator, give me a sec. 1, 2, 3, 4, 5, 6, 7, 8. And now you give you approximately about 199395450.1. So approximately about. So this is approximately 2 times by the power of 10. 1, 2, 3 by the power of 8 meters per second.